us, though. And I probably have no idea what it's going to talk about. But anyhow, thank you, Pastor.
Thank you so much. Thanks for having us here. Almost every week this month. So my name is Pashu Christensen, and I'm with the Hive, and I'll do a very short introduction about the Hive think tank and the Hive tonight because unfortunately Ravi, the founder, couldn't join. So the Hive think tank is one of the largest community of data scientists, engineers, practitioners, developers, all focused on big data. We host events every week with from 200 to 700 attendees. And so we've hosted over 100 events. We have over 6,000 members, and you are part of the members of the community. And we hosted over 200 speakers. These are two upcoming events this month. So join us at Strata next week. Even though you don't have a pass for Strata, you are still welcome to join this event. It's open to the public. It's in the San Jose Conference Center, and it's going to be on music and big data, and we'll have an after party with DJ Alistair Kroll, who happens to be the chairman of Strata, and we'll have some drinks, so it's going to be fun. You are all welcome to join, and if you want to listen to some good music and hear a good panel discussion. And then we have an amazing panel discussion on February 25th on the Lambda architecture, so don't miss this one either. We'd like to thank our sponsors tonight, as well as our partners, and especially Perkins Squibb for hosting us tonight. A few words about the Hive. So the Hive is an early stage data-driven startup incubator. We invest from 1.5 to 3 million in each one of our portfolio startups, and these are our focus areas. And Kosei, you might have heard, just got acquired by Pinterest 2 weeks ago. We have some other exciting news coming up these coming weeks. So EI Security, Deep Forest Media, they are all on our website, hivedata.com. And of course, we are hiring just like all the tech companies, and one of our IoT startup companies hiring, especially these days. For tonight, make sure to continue the conversation online. The hashtag is hivedata.com, and we are at Perkins Squibb. And post pictures, ask questions, and we will make sure to follow you. And with this, I would like to introduce Michael. He's the co-founder at KNIME, and he's been a professor as well, and he's been teaching at UC Berkeley. You are a professor as well at Clemson University. And he's the co-author of 2 books. So he's used to speaking in public. He should be a good speaker. And with this, I'll open your presentation and I leave the floor to you. Thank you very much. Thanks.
Thank you, the Hive, and also to Ravi for giving me the opportunity to talk here. I think that's a rumor. Most professors are terrible speakers. So I'll try to prove them wrong, especially the German ones. They're all bureaucrats. Anyway, so I'm going to talk a bit about KNIME, so maybe we'll set the stage. Who here knows, now you know, who didn't know until a minute ago how to pronounce KNIME? Okay, who here has touched KNIME at least? Downloaded it, played with it a bit? Okay, so I'll probably bore you 7 people here and there a bit, and the rest I'll hopefully tell you a bit more about Open Analytics Platform, why we think KNIME is a really cool thing, and the rest of you all should download it and start playing with it. Okay, so the agenda for today, if this thing worked, it doesn't. That's because, interesting. That's because the battery is empty. I think it's red, but that can be fixed. I have another one.
Yeah,
Not
you
works.
just have to plug it to the
I'm
I'm not sure.
That's not good. One of these runners. Okay, good.
Great.
So what I'm going to do, I'm going to set the stage a bit by talking a bit what we believe a modern analytics environment ought to be, what kind of requirements that should fulfill. And I'm going to look at that from 3 angles. I'm going to talk a bit about sort of data, where data is going in the future. I'll be talking a bit about where methods will be going in the future. And I'll talk about what people will be doing with data analytics, advanced analytics type methods. Okay? And all of that is my personal opinion, and as we all know, all predictions are bad, especially when they're about the future, but I'll try to at least say something interesting. And then I'll sort of, from that, I'll lead over to KNIME. I'll talk a bit about sort of general features of KNIME, and I'll try to give you within sort of half an hour sort of a rough overview what KNIME can do and what it looks like and how it sort of kind of works. For the more technical affine people here, I'll also take a very quick peek under the hood and talk a bit about technical insights, but really only 5 slides. If you have any more questions, there's a lot of material also online, and I'll point you to that afterwards. And there's going to be 3 very tiny commercial breaks, just to warn you, because most of what I'm going to talk about is the open source platform, analytics platform. Okay. This has a fresh battery, I know that for sure. Much better. Okay, good. Modern requirements. So data. We all know that. All of you are data scientists. We used to be called data analysts. Now we're data scientists, especially in Silicon Valley. It's all about numbers, and used to be text, and then things like network and graph mining started popping up. There was interesting. Text mining was a huge thing about maybe 5 years ago. That's all more or less solved problems. And then, of course, there were a lot of these more application-specific type of things. Most prominently, probably things like sequence mining in bioinformatics, right? That's all pretty known stuff. That's something we kind of know how to do, right? What's currently going on is more, right? All of this big data stuff, and I think the driving thing here is really the Internet of Things, and there are different ways of looking at that. You have sort of the variables, all of this personal data collection that people are doing to better monitor themselves, and then of course all of the social media stuff, big thing. We're working with the Deutsche Telekom, for instance. They're trying to analyze online forums, identifying, excuse my words, but shitstorms before they actually happen, that type of stuff, right? And then of course, on the other side, you have all of the engineering type things, predictive maintenance, manufacturing, what Siemens calls it, Industry 4.0. And interesting here, we're collaborating closely with Bosch Software Innovations, and they're using KNIME as an analytics engine within their Internet Suite of Things. What's next? Next, in my opinion, is we are going to get so much data that we're going to have trouble storing it. So this idea of shoving everything into Hadoop and then later analyzing it, that's going to die on us. Funny thing is, we've had that before and other people have solved that. In physics, particle colliders, people really only store 1% of the data. So they have really smart mechanisms to, while they record it, already discard most of the data they have. So I think transporting some of these ideas over to other types of analytics problems is going to be really, really interesting. And the other thing is even faster data, right? Where you actually have so much data coming in at such a fast pace that you need to very early on during the collection stage already dispose a lot of it and not even bother looking at it a bit much, much closer. So I think that's going to be a very, very interesting challenge for a lot of tools dealing with much bigger data and really, really fast data. And then one of the things that sort of my own heart beats for is truly heterogeneous data. So really trying to analyze things that come from different domains and make sense of those and find patterns in one domain and try to identify those patterns in other domains as well. And tons more stuff, who knows, right? And that's actually an interesting trend in advanced analytics. I talked with the CEO of Siemens Industries a while ago, and he was actually very honest. He said, I don't know what kind of data we're going to collect in 2 years, and I really don't know what we're going to do with it, what we want to do with that. Okay, methods. Same story, we all know the neural networks that everybody played with, clustering methods, and then decision trees, all of the classics. That's the things that we all learned in grad school, I guess. And now what people are doing, we're now sort of neural networks got dumped. I'll get to deep learning in a second. Now support vector machines are a much more formalized way to deal with neural network type problems. We have random forest, decision forest, all of these ensemble methods. And then deep learning is also popping up. I find this interesting because it's essentially just saying we're doing the same that we did in the past. We just do it with a lot more compute power. We're not doing smarter stuff, we're just doing more of it. Deep learning is just many more layers. That stuff here, Torsten, right? We tried to do that, 25 years ago at CMU. All the Spark stations were busy running backpropagation on some 3-layer neural networks. Now it's 8 layers, and you're just throwing GPUs at them. And random forest, same idea, right? We're still building decision trees. We're just building tens of thousands of those, and we get a bit better. But we're not actually doing smarter stuff. We're just throwing more compute power at it. So I think what's going to come next, and this is really a very personalized view, I think we're going to look a lot more in using distributed resources smarter. So we need to find algorithms. We need to revisit all of these heuristics that we had to, in the model searching part, that we introduced because we didn't have the compute power. Now we have tons of compute power, even more data, but the compute power is distributed, right? So we need very smart ways of finding interesting solutions, good solutions, better solutions, in a distributed way, in a global search space, without really a lot of communication overhead, right? That's going to be very interesting challenge. We call that widening at University of Constance. We have a couple of ideas how that can be solved. And then one of the other things that we've been working on in the past, by associative knowledge discovery, really trying to find interesting patterns in data that comes from different resources, from different domains. Really sort of looking, we had a couple of examples in this book that are described, where we were looking at financial data from a financial domain, and mapping that, trying to find patterns that repeat in the biomedical domain. Also, very interesting approach. And again, who else? Lots of other. University of Constance is not the only university working on these types of topics. There are tons of other research groups and also industrial research group out there that are coming up with new methods for really smart data analytics on a daily basis. People. It started off, the data analyst was sitting in the corner in the organization. He or she was waiting for questions sort of kind of tossed over the wall, and then she or he was using the favorite tool, doing something, 3 days later passing back an answer, right? It was the gig, it was not really mission critical for the enterprise, or something, every now and then, interesting cool questions. Then the data analyst got renamed to be the data scientist. It's now much less of statistics, machine learning, that's still in there, but we're now doing more data mining, visual exploration stuff, so it's not necessarily so much about answering questions precisely with significance boundaries, but coming up with interesting questions to ask almost, right? You're trying to find a pattern in the data, and then afterwards you go deeper in and say, okay, is this really valid, the pattern? So a lot of this is much more explorative. But you're still sort of doing that by people that are sitting there. So our claim, what you really need from all of these, you don't really know what kind of data you're going to have in the future. You really want to pull all of that stuff together. What you need is some sort of a platform in the middle that ties all of that stuff together. It allows your data analyst very, very easily to reach out to all of the data sources that you have, new ones, in-house, external data sources. It allows what your data analyst generates to be used by business analysts, people who may not be able to build the analytical script, workflow, whatever from scratch, but may be able to use it and interpret the results. And you want to not just replace old legacy tools, but you want to integrate those as well, be able to call out to the existing IP that you already invested a lot of time and resources in, right? So pulling all of that stuff together within the framework of an open analytics platform, that's what we want to do. That's something that empowers casual analysts, business users, to actually reach out and use advanced analytics, right? They would never be able to do that from scratch, but if it's sort of carefully put together, they can actually make use of that. I'm not a huge fan of this term analytics for the masses, because I strongly believe in the end, if you run something, you still need a bit of knowledge about the underlying methods to truly interpret what you're getting. But that's a different story. We can have a discussion about that. Okay, so the model requirements, in our opinion, for future-proof advanced analytics really requires integration. You need to be able to combine the tools, right? People got a choice. You can't just say, okay, here's a monolithic application that has these algorithms, you need to use one of those, right? And by the way, we can only read that type of data, and you're out of luck if some other data source pops up tomorrow, right? So you want to integrate the tools, you want to integrate data, you want to be able to reach out to the legacy tool that your colleague wrote 15 years ago. Nobody really knows anymore what it does under the hood, but everybody uses it because it's doing something really cool, right? And external tools, just being able to quickly call out to something else, trying out a new bleeding edge algorithm that was published. Is it really better for our type of purpose, and without having to wait for your tool provider, for your monolithic tool provider to implement that? Collaboration, you need to be able to exchange science, you need to be able to exchange best practices, you want to be able to reuse what your colleague was doing, right? They built a really cool analytical workflow. He wrote it in R, you're a Python programmer, you're out of luck, right? You need to be able to somehow hand these things over. Transparency, of course, reproducibility, wisdom transfer, we call that deployment, being able to take these analytical, whatever it is, right? You do really cool advanced analytics, you need to be able to hand that over to other people. They need to be able to see that, understand it. It needs to be very, very transparent what happens. Agility needs to be very quick. You want to explore alternatives, try out something else, try out a different algorithm without being restricted by one particular tool, but it offers you what kind of data you can read in. And all of these four together in a way just make it much more powerful. So it's not so much the platform alone that's the more powerful tool, it's the combination of all of these tools that really, really makes it powerful, because you use what you need, not what you're allowed to use by your software vendor. So in the end, schematically it should look something like that, right? I mean, you have boxes where data reading happens, you read data from the cloud, you have some proprietary data sources that you're reading in. The usual, you do some transformations, cleaning, joining, and maybe pieces here are coming from Excel, something here happens in Python, whatever. You do visualization analysis of your data, and then maybe you call out to some of the legacy, some in-house tools, some other cool stuff that's sitting out there that you also want to use within the frame of your advanced analytics workflow. Almost needs to look like something like that, then you deploy, you write it back, the data, or you build a nice little report, right? And obviously parts of that ought to be running on Hadoop in the end as well. So if you could mix and match there as well, perfect. You're not going to run everything on Hadoop, right? Not that many problems really are big analytics problems. A lot of problems are big ETL, transformation, aggregation problems. In the analytics, you need to run on a carefully understood data set anyway. Maybe wrong, maybe you want to reach out to
What is that
analytics.
symbol underneath the join?
Sorry?
What is that symbol underneath the join box there?
This one? Python.
Oh,
Sorry, yes, Python symbol. And then other stuff, right? The question mark is a question mark. You don't really know what else you want to use. Okay, so you could do it like that. The expert would write whatever, right? I mean, there's a bit of, this is just a bad example of a bit of SQL and a bit of Python and a bit of R. But in the end, this is not going to work, right? You're not going to find. You give that to somebody else a year later, probably the author doesn't even understand it anymore. This is not reproducible type of science, right? So what you really want, you want that. And this is what KNIME gives you. KNIME, if you model such a workflow in KNIME, it looks like that. Right? You have a couple of these gray boxes are what we call meta nodes. They encapsulate a bit more, but it sort of allows you to document visually what you're doing. Right? So in the end, this is just visual programming, absolutely. But it's very powerful because visually, you put it together visually, and while you do that, you document what you're doing, and other people will understand that. And I'll show you in the next couple of minutes how powerful this really is, because it allows you to wrap SQL, it allows you to wrap R, it allows you to wrap Python, and sort of expose that to others. So this is really a KNIME workflow, and this is what it looks like in KNIME. So you really have your workflows here, you have all of these modules down there, and then you just plug it together. So you can download that and try that. That's a real workflow that actually does something. I don't actually know what it does, but it does something. Okay, so let's dive a bit into KNIME. I'll try to give you a bit of an introduction what it does. I have 3 slides on us as the company. How do we make money? Maybe that's also interesting. KNIME, the company, was founded in 2008. We have our headquarters in Zurich. I'm based in Zurich. We have an office in Berlin, and we have an office in Bay Area. And Jay sitting here, and Aaron, Aaron over here are our two people in the Bay Area. So if you have any local questions, reach out to those guys. We have about 20 people. And what we do is the KNIME analytics platform, pretty much everything I show you today is open source. You download it, try it, it works, you can do it, scales, it runs, whatever. No limitation, nothing. I don't believe in light open source or whatever, trialware, it's all. That's not the idea. So what we do is we provide proprietary layers on top or underneath the platform, a bit like Cloudera, that allow you to use KNIME in a corporate context, collaborate using KNIME. And I'll show you a few examples of that. But KNIME itself, you can do everything you want to do in KNIME. It may here and there be not quite as comfortable, because it would be nice to be able to have a server infrastructure to exchange workflows. That's something we provide as a company, and that provides our income. Okay, so it's open source, it's GPL version 3. It will stay open source, not only because we like open source, but it actually makes a ton of sense to leave it open source. I'll get back to that in a second. I mean, there's some other out there that sort of abandoned open source later, once the investors stepped in. That was interesting. We have a biannual release cycle. Current release is 2.11, 15 open source releases, so this has been going on for a while. It's Java, it's an Eclipse RCP. And Jay always complains when I show lines of code because it doesn't really mean much. What we essentially want to say with this line is there's tons of work that's already been invested in KNIME. A lot of that code is built nightly and tested nightly. We have an extensive set of KNIME workflows that run every night, and we are 100% backwards compatible. So our workflow test system still contains tons of workflows from KNIME version 1.0. The nice thing here is that's our code. That's the one we provided in the open source. This is code that comes from the community. They're adding stuff where half of it we don't even understand what it does. It's highly scientific analytics engines for chem informatics or for text mining that provides real cool additional functionality to KNIME. That's also these 600K lines are also part of our nightly test system, so they also can be trusted. We have a very active developer community, obviously, and very vibrant community support. I always cite that the fraction of KNIME's support questions that are answered on our forum and the fraction of answers from KNIME is going down over time. We are actually answering more questions, but relative to that, the community is taking on many, many more of these support requests. So it's a very, if you ask something on the forum, you usually get an answer within an hour or two, even if everybody in Zurich is asleep. Just sort of briefly about the software ecosystem, how it all is all put together. The KNIME Analytics platform, we'll be talking about that mostly. And then we have a few things that plug in. This is this collaboration infrastructure that really allows you to share workflows and deploy workflows in a larger enterprise. And we have a cluster execution extension that allows you to run KNIME workflows on the SunGrid engine or Univar. We have a couple of productivity extensions. I'll briefly mention those. And these are all of the partner and community extensions that are plugging into KNIME as well. Good. What's KNIME? How does a workflow really look like? So you start with a node. These nodes have, I mean, those of you who have seen, I don't know, Enterprise Miner or something, that's not, the idea is not new to model that as a workflow. There are a couple of interesting technical things that are new and that are fairly unique to KNIME. I'll get to those in a second. So you have a couple of imports, data coming in, or it can also be something else coming in. I'll show later how a database connection can go in. And you have stuff coming out. In this particular case, very boring node is just partitioning the data. Table goes in, 2 tables come out. And you can somehow configure that node, and the node can have 3 different states, so visualized by this little traffic light. The red one, the node has no clue what it's doing. The yellow traffic light indicates that, yes, it's configured in the right way, it knows what it's doing, and it can do that with the data that could potentially arrive. And the green one means it's executed. So at every step, you can investigate this node, you can look at it in isolation and just look at the data and see if the node actually did what you're doing. So while you assemble that workflow, you almost visually debug on the way if the workflow is really doing what you wanted to do step by step. And then these nodes, we just chain them together and create a graph, and that models the data flow and how it's being processed. So we're reading data, we're adding some color information, we create some statistics on the data so you can branch off. Doesn't really matter, you partition, that's the node from up here. Here you train a decision tree, and you already notice that it's not always data that's flowing, but in this particular case, it's actually the little blue port tells you this is a PMML document that's flowing from this node, transporting the decision tree. So this is not carrying data, but that's actually carrying a model. And there's a couple of other of these port types as well. And then we do some statistics down here for the quality of that. Okay. This is what KNIME looks like when you download it. I mentioned that before. You have this canvas in the middle where you assemble your workflow. You just drag and drop modules from here over there, and then you just connect them, dragging by mouse, or there's a couple of shortcuts as well. Whenever you select a node, you instantly get documentation over here. It turns out it's a very easy way of getting geeks to write documentation. If you don't provide the XML file with your node implementation, there's a big pink warning message that's so offensive that people will write documentation. So we have tons of nodes here, over 1,000 nodes by now, plus the community nodes probably adds another 300-400. And up here is your workflow repository, right? That's all of the workflows that you assembled, you open them, close them, save them. So very intuitive. Whenever you save a workflow, you can save it in any state. Some nodes are executed, some are just configured. It's still disconnected workflow, whatever, it doesn't really matter. Next time you continue, you get exactly that state back. Okay, let's walk a bit through this workflow that I showed at the beginning. We'll just dive into some of those, and I'll show you a few examples of things that you can do here. I'm not going to touch upon all of the 1,000 nodes, but I'll try to give you at least an overview. In terms of reading, if you just go into the I/O category, you open read, and you see what you can do here. There's obviously the file reader. There's a specific file format reader. We have a PMML reader that reads these PMML documents. You can obviously access Excel files, read the different sheets, and then you can literally iterate over sheets and read them into KNIME as well if you want to. And then there are a couple of specialized readers. We have a reader for XML documents, we have a JSON reader, and these, I'll talk about those a bit later as well. You can also use R or Python to read in data, right? R has a very nice routine to read SPSS files. Why bother writing our own SPSS reader if that already exists in R? So you can just wrap that in here and properly configured. Whoever uses that doesn't even necessarily need to see the R. One example what this looks like when you pull it over, so you drag the node onto the canvas, you drop it here, it's red. You right click or you double click and choose configure, and the configuration dialog pops up, right? And that the configuration dialog of each of these nodes is fairly individual. It almost takes you by the hand and tells you, okay, this is what I need to know in order to operate. You don't need to remember command line parameters or figure out what are the parameters of this function call, but the node tells you what it needs to know. I want a file name. I'm going to give you a preview. This is almost like the Excel file import with tons of little options. This is probably the one node where we invested most development time. Really, really ugly. Types of different file formats you have. Send Peter Owl at KNIME.com a thank you message if it's reading successfully a really strange file format. He's going to be very happy. I think he regretted starting writing the file noder. This will never, never, ever be finished. Anyway, reads tons of stuff. You need to get the data into KNIME to continue. We have Twitter connectors. We have Google API connectors. There's ways of reaching out to REST and SOAP web services. And of course, we have other sources. There's a weblog reader. You can read in images. Omero is an image database for gigantic image databases, cell images, things. You can read it, various network formats. XML I mentioned, and there's a document grabber that goes out to the internet, for instance, PubMed, and downloads abstracts from PubMed. And we have a little reader. Thanks to the community, there's a nice library out there that reads SAS file formats, which are actually pretty nasty to read. We wrap that into a KNIME node, and we can now also read SAS datasets. And of course, databases, right? How do we databases? We deal a bit we handle those a bit differently, because early on we had a database reader. We just sort of, okay, read this table from the database. So we saw that, and the next node that I saw in the workflow was a row filter. We went down from the 2 million rows that we went down to 4,000. Said, you know what, databases are made to do that. Maybe we should somehow allow the user to stay inside the database a bit longer. So what we do is we just connect to the database for now, and then we model a few of the things that can still happen in the database. There are different connectors. SQLite, of course, doesn't need a database URL or anything. You're just pointing it to the file. And another one, the MySQL connector, of course, needs the host name and database name and the user credentials and so on in order to connect. And we have a couple of other of these connector nodes as well. And then, I mean, there's a generic one that just needs a JDBC driver, and then you can connect to any other database. We also have a few more that we sort of personalized. And the nice thing about this personalization means that we can actually model some of the slight differences in how they treat the SQL standard, right? So in row filtering or something. And that's something that we can then translate so it actually works with that particular database. So this is what a tiny little in-database workflow could look like. You're connecting to a database. You have two different nodes selecting different tables in that database. One does a grouping operation, another one does a column filtering, then you do a joining. And all of this stuff that's here still modeled via red connections happens inside the database. So KNIME is just controlling what's happening, but we let the database do the work. And this node finally pulls it into KNIME so we can run some of our native algorithms. Okay? The nice thing is, of course, the nice thing here is essentially I'm allowing people to write SQL, limited to a certain extent, but they can write SQL without ever touching SQL. This is the statement that this sub-workflow will finally issue to the database, right? If I do that, I can of course also change that connector and connect Hive or Impala or ParseStream. And out of the sudden, all of that stuff runs inside Hadoop. So all of the ETL aggregation stuff you can very easily model. You can design it with your little SQLite desktop database, whatever. You change the connector node, voila, it runs somewhere else. Okay? So this is our first approach to sort of doing ETL in Hadoop. We have some other stuff in the works as well. I'll mention that towards the end. And then there's of course an Impala connector, and there's a Vertica connector. And that's sort of the first commercial break. One of the things we offer, it turns out who here has tried to access Impala or Hive? It's a mess getting all of the right drivers and all of the right versions and everything together. So we worked with Cloudera and with Hortonworks and made sure that we have a bundle of the right things that work with a certain version of their distribution. So this is just a service you can purchase from us for not a lot of money, what we call the big data extensions, and they contain certified by Cloudera and by Hortonworks specific connectors where you know it works with a particular version, right? You can do that yourself. I mean, it's not that much work, and we're happy to help. I mean, you just need to make sure that all of the libraries and all the drivers, you collect the right one, put them in the right place, then you get exactly the same type of functionality. But it's sort of, it's like a mini part distribution that sort of wraps the right stuff in the right places so you know it works out of the box. Okay, let's dive a bit into transformation. You hear transformation, everybody falls asleep, it's boring, right? Who cares about transformation? Problem is, of course, it is 80% of the time that you spend. You have to massage the data into shape before you can actually use something. We have tons of stuff in transformations. We have over 300 nodes, from very, very simple ones, filter a column, filter rows, do this, skips that, to more complex things, pivoting, grouping, advanced string manipulation, all of this little cleaning up that you want to redo every time you run your analysis workflow on updated database, or on updated data every night or something. You can model that as part of this stuff. We have another 100+ nodes for more type-specific operations, doing something with images, with texts, with molecules, with networks, whatever. There's tons of stuff in there. It's the yellow nodes. They do the pre-processing stuff. If you look at real-life KNIME workflows, they're predominantly yellow, unfortunately, but that's life. Does it work? It works. We usually get ranked very, very high in data manipulation capabilities, ease of use. That's the Rex Analytics survey 2 years in a row. And also Gartner in the Advanced Analytics Platforms report from last year, we actually ended up in the leaders quadrant. That was a nice surprise next to company. I've never heard of SAS and IBM, strange little companies. High levels of satisfaction with data access, data filtering, manipulation. We have actually very happy users, and we're very proud of that. And the nice thing is, I'm not allowed to say that, but I saw the draft of this year's Gartner report. We moved even further up a bit. So another nice surprise. Good, so transformations, we have it, it works, it's all there, you can do tons of stuff, and it grew over the years, right? I mean, whenever we assembled KNIME workflows, we realized, oh, this is annoying, I need to use 3 nodes for that, we created a new node. Sometimes we even had companies come to us and say, oh, this is really annoying, we're going to give you a bit of money. They sponsor the development, and we add a couple more for the pre-processing nodes, transformation nodes. Okay, let's look at the stuff we actually care about, the analysis. So this is, you kind of saw that in the small example workflow already. This is how it works. You can do a partitioning into training data, into test data. You feed that into this node. This node, you open the dialog, it will ask you the things that has the meaningful default settings, but you can mess with all sorts of settings, change that to Gini index or something else. And the model that falls out of here, you feed that into the predictor node, and the predictor node will take a model and the data and will add an extra column with a prediction, right? And we have many more of these nodes. We have naive Bayes and a couple of clustering algorithms, rule induction, neural networks, decision trees. You see that here. Nearest neighbor, what else is there? Here's an example of a community integration. The libsvm, really a highly efficient library for support vector machines. We're integrating that with our own learner predictor as well. And they all follow the same schema. You have a learner that creates the model, and you have a predictor that takes a model and data and sort of applies that model to the data. And that doesn't have to be part of the same workflow. I could also have a workflow that learns a model every night, that runs on the server, regularly scheduled, creates the model, puts it somewhere in some other workflow, uses that to predict classes, outcomes, whatever, whenever new data arrives, for instance. Okay? So that's the basic stuff. We can, of course, also do things like cross-validation, and essentially all you do is you wrap that into this looping context. This does the partitioning corresponding to how many folds you want to run this on, and the X aggregator just runs this 10 times, whatever the settings are, collects the statistic and spits them out. We, of course,